Okay, so before we lost the connection, we were looking at the characteristics of an algorithm, and we have seen some basic characteristics. Now we have the steps for developing algorithms. I think we have looked at that. You need to define the problem that you are solving. When you define the problem, you need to identify what are the inputs that you will need and what are the expected results, okay? And then you need now to describe the steps that are involved in converting those inputs into your outputs. So that is basically how it is. If you are writing an algorithm to manipulate a data structure like an array, I believe last year we saw the array data structures. If you want to write an algorithm to display all the elements of an array, for example, you need to identify what do you want to do. The problem is that you want to display all the elements of an array. Now, what do you need as an input? What you need as an input, maybe it should be an array, okay? And now what will you do on that array to display all the elements? That is now the logic or the processing that you need to execute. And that is how it is, okay? As simple as that. Okay, and at the end, you need to be able to test your algorithm if it is working well, okay? And I believe in subsequent lectures, we will see, we'll have a study on the efficiency of algorithms, because it does not suffice to just write an algorithm that is working. The algorithm needs to be efficient. It needs to show that it is using resources efficiently. Okay, like for example, you can write, A can write, or NJ can write an algorithm that is calculating the student GPS, and the algorithm is taking 1 minute or 60 seconds to run. Bernard can write the same algorithm that is taking 2 seconds. Maybe Blessed can write the same algorithm that is taking 1 hour. Cherby can write the algorithm that is taking 30 minutes or 30 seconds. So you will see that, but all these algorithms are working actually. They are giving, they are calculating the GPA. But then which algorithm is most efficient in terms of usage of resources? You need to be able to test your algorithm to make sure that it is using, or that it is efficient in the usage of resources. Okay. Somebody is asking the question, what is data set? I believe we are going to see data set as we are going to see more of data set as we will proceed. Because when you look at test the algorithm on a data set, it simply means you need to do like what? If your algorithm is to calculate the GPA, like we said, you need some input, right? You need some input, and that input is going to be some data. What we mean here is that you need to select some sample or some data on which you can perform this test on the algorithm. That will be a data set that you are going to use to test your algorithm. And it is the same, even when your algorithm is going to run, when you will want to calculate the GPA of student A, for example, you will need some data about the student to calculate that GPA. That is a data set, okay? You might need to calculate about student X or student Y. You will need some data set, which is the input to that algorithm to be able to get the expected results. So I believe in most, when we go deep into algorithms, you will understand the different data sets that you can have. The data set could be a combination of different types. It could be strings, it could be integers, it could be objects. Depending on what your algorithm is doing, you will have different data sets. Okay, so you select the appropriate data set that you can test your algorithm. So you should not write an algorithm that you are expecting it to manipulate integers, and you go and choose a data set that is characters to test this algorithm, you will not have your expected results. Okay. Now we have what we call structured programming. In structured programming, you have what we call control structures. So basically in your programming or in your algorithms, you will have these control structures. And these control structures are intended to do what? To control the manner in which the instructions in your algorithm are being executed or shall be executed. Because you can have an algorithm that is made up of 10 instructions or 10 statements. Okay, how are these statements executed? Are they executed in a sequence, one after the other, like statement 1, statement 2, statement 3? Okay, or are they executed in or are they executed as a selection, like you select some set of instructions and execute? So it depends on what you want to do. Okay, so we have the selection, we have the sequence, we have the selection, and we have the repetition. For the selection, for the sequence, for example, for the sequence, you will have a situation, if you have an algorithm that is doing what? Let's say in your algorithm, you want to, or let me just say you have instruction statement 1, statement 1, statement 2, statement 3, statement 4. Maybe your algorithm is like this. It's made up of these steps. You have statement 1, statement 2, statement 3. Maybe statement 1 is to print the name or to display the name. Statement 2 is to print the date of birth. Statement 3 is to print the place of birth. Statement 4 is to do what? Maybe to print the department, for example. Okay. In a sequence, if these statements will be executed in the sequence, it means they will work like this. Statement 1 will be executed. When your program will run, you will print the name, it will print the date of birth, it will print the place of birth, it will print the department. Okay. This is a sequence or a sequential execution. Now we have a selection. In a selection, you have particular structures that you use to implement selection. In selection, for example, in programming, generally we use the if else and the switch statements to implement the selection. Okay, it means you want to you don't want to execute these instructions in the order in which they appear, but you want to select which instruction to execute based on a particular condition. It means you will have these instructions like this: statement 1, statement 2, right to statement 4. But with the selection, they will not be executed in order. It means you can decide and execute statement 4, or you can decide and execute statement 2, skipping statement 1, based on a particular condition that you verify. Maybe you just check a condition that this student is a female. If the student is a female, don't display the date of birth. You know, girls do not like when we know their date of birth. Okay, you can just do a selection here that if gender is female, for example, then you will just say execute statement, you just say statement 4. You should just print their department. You should just say statement 4, for example. In this case, it means that these instructions will not be executed. the other statement 1, statement 2 will not be executed. You are selecting which instructions to execute. We'll look at a typical example in this case, okay? I think we saw an example like this already, like making a decision that if a particular condition is verified, you should perform this other instruction. Else, if it is a different condition, you perform this instruction. And like that, you are being able to select which instruction to execute. Look at how the instructions are appearing. You have go swimming, play golf, watch television. These are instructions. This is the order of instructions. If it is in a sequence, you will go swimming, you will play golf, you will watch TV. That is the sequential execution. But now, if it is in a selection, you are going to go swimming if you check a particular condition. And you can skip this going swimming and playing golf and execute this other instruction based on what you want. In that case, the instructions are not executed in a sequence or in the order in which they appear. Okay, I don't know if it is a little clear. Those who have their cameras on can turn them off. Okay. Now we have the repetition structure. Repetition is a situation where you want to repeat the execution of some statements. You want to execute some statements repeatedly until a particular condition is verified or is evaluated to be true or false. So it means what you do is that you want to select a particular set of instructions, one or several instructions that you will execute based on if a particular condition is evaluated to be true or false. People who have their cameras on can turn them off. They don't need cameras now. Celestine, you can turn off your camera. When it will be time to see you, we will ask you to switch on your cameras. And I'm sure you will not like to see some people where they are at the time. Celestine, can you switch off your camera? It's not yet off. Your camera is not yet off, Celestine. You need to turn it off. Okay. Okay. I see a question from GK Alvin. Is assignment a control structure? Another question from Shifu. How is a repetition structure different from a loop? Okay, the first question is assignment a control structure. Assignment is not necessarily a control structure. Assignment is a statement, okay? An assignment is a statement. You can apply a control on that statement, okay? Assignment is a simple statement that you can say name equals GK. For example, you are assigning GK to the variable name, okay? Or you can say surname is equals GK. It means you are making an assignment. Or you can say X int int x equals 1, you are assigning the value 1 to the variable. That is a statement, okay? And now you can decide to execute this statement if you have maybe assigning first name to a variable, last name, middle name, or date of birth to variables like this. You can do them. You can execute these assignment statements sequentially, or you can decide to apply some selection or whatsoever on these statements. Okay, so this is just a statement, and you can decide to say, okay, this statement I want to execute after I verify a particular condition. Okay, so when we talk of control structures, they are just the structures that are used to control these statements, like the assignment, the addition, operation, subtraction, and all of that. I don't know if the answer is a little clear. So an assignment is not a structure on its own, but it is just a statement. And then that statement can be controlled using a control structure. Okay, it's okay for GK. Now, Shifu, repetition structure different from a loop. Okay. Now, when you talk of a loop simply means you are doing something in let me say repetitively, right? You are doing something repetitively, or you depending on the let me say the jargon that you are using. If you say you want to do something in a loop, you can use a control structure to implement that loop. For example, if you want to display numbers between 1 and 1 million, okay? If you want to display numbers from 1 to 1 million, what you can do is that you can have a loop to do this. And to have a loop, you can do what? You can use a repetitive structure. You can use a repetitive control structure to do this. Means that what? You can do a kind of a checking for maybe for numbers, you can define a variable in number, and you say for number between 0 and 1 million, display number. That is a loop that you are implementing, and you are implementing using a repetitive structure. It means the display number will be executing repetitively as long as the number is between 1 and 1 million. That statement will keep on executing. It will execute, go out of the loop, check the condition, execute, and it will execute like that until the condition will be verified to be false, and then it will move out of the loop. Okay, so that is to say that if you want to say a repetition structure, you cannot really be comparing it with a loop, because the loop a loop is like you want to execute several instructions you want to execute an instruction several times, okay? And then you can do this using a repetitive structure. You are doing this using a repetitive structure. You use a repetitive structure to actually implement this kind of a loop. Okay. And a loop in this sense can also be a condition. You can just loop in a condition, because looping, I don't think is actually the right word to be comparing with repetitive structure, although you can use one to implement the other. You can use a repetitive structure like the for, the while, and then you implement a particular loop that you want to, a sequence of instructions that you want to implement. Maybe a loop is just another way of calling that. Okay. Check. No more comments. I don't know if it is very clear, Shifu, but we can come back to that. If you still have some other doubts on loop and repetitive structure, we can come back to it. Not a worry. Okay. So now we said we are going to use object Java programming in order to implement the algorithms that we will have. For example, very soon you will start looking at arrays, you will start looking at trees, you will start looking at stacks, you will start looking at linked list data structures, and you will need to implement these data structures. Okay, you will need to implement them, test them on the programming language. Once they will explain, you will understand the logic or the algorithm behind linked list, or the algorithm behind the manipulation of arrays, maybe inserting an element, deleting an element, displaying an element. You will need to now do what? You will need to now implement this array on this using the Java programming language. Okay. All right, so now we have the concept of objects. When we talk about Java programming language, we have an important concept, which is the concept of object. Now, the concept of object is in computer is not very, very far from real life objects. For example, when you just look around you, you see objects. You yourself, you are an object, okay? Your table is an object. The course you are attending is an object. Student is an object. Department is an object. So everything that you have as nouns, normally these are objects. A dog is an object. A bicycle is an object. A car is an object. Okay? A bicycle is an object. A tree is an object. Now, these objects can be represented in software also. You can also present software objects, which are representing these real life objects. It means if you want to manipulate maybe students, you consider a student already as an object. If you want to write a program that is dealing with students, you can transform this student that is a real life object into a software object. Okay, you can actually translate a student into a computer or a software object. When you look at the objects that we have, at the real life objects that we have, you will see that objects have what? They generally have some characteristics, okay? They generally have some characteristics that we look at them as the state of the object. For example, look at the student. A student will have a name, it will have a matricle, it will have date of birth, it will have the department, it will have some particular characteristics. And these characteristics define the state of the student, the state of the object student, okay? So that's generally what you have. Even with the tree, a tree will have what? It will have the roots, it will have the stems, it will have the leaves, okay? Those are characteristics or states of a tree. If you take another object like a bicycle or a car, for example, a car is also an object. A car has what? It has a speed. Huh? The number of kilometers it can cover per second. It has what? It has what again? It has the gear. It has what? It has tires or number of tires. It has, in fact, it has some attributes that define that car, that you'll be sure that if you find any object of that type, that object will have all these characteristics. For example, if you say that a student has these characteristics, name, date of birth, sex, matricle, you should be sure that any student that you will pick, will have all these characteristics that you have identified for the student object. If you say a tree has some particular objects, some particular states, you will see that any tree that you find in the world will have all these features that will make you to identify that it is a tree, okay? Every tree will have the roots, every tree will have stem, every tree will have leaves, like something like that, okay? Now, In the objects, you also see that the objects have some methods or some, how do they call it? They have some functions or some behavior, okay? They have some behavior or some method that they portray. For example, if you take an example of a student, we have seen that the student has a state and he has, we have seen already about the state of a student, that the student is what? It has all the attributes, the characteristics that we have seen. Then what about the behavior of an object of type student? The behavior is that the student should be able to do what? To attend lectures, for example. The behavior is that the student should be able to come to school. The student should be able to write exam. The student should be able to be promoted from one level to another. The student should be able to update all this its states. It means if you have an object student and he has a name, there should be a way to, if you want to create a new student object, maybe another student that is just coming in, that you classify as a student, you should be able to give them a name. You should be able to give them the date of birth. In fact, you should be able to define all these characteristics that you have, that they need to have. You should be able to give them these characteristics. Okay, so that's why we will, in object-oriented programming or in Java programming, the concept of object is very critical. You need to look at every element as objects, and they are not very different from real life objects like we have explained. Anything that you see around you that is an object, like every noun is an object, a computer is an object. Okay, so that is how you will look at it. Now, we are going to see how you can translate these real life objects into actually computer objects, how you can represent them in the computer. You will be able to present their characteristics, which is the state. You'll be able to indicate their behavior, which is like the functions that they can respond to, okay? A student will not normally bark like a dog, for example, because it's a student, all right? Okay, let me see another question from GK. If we say an object is a collection of data and methods that act on the data, is it correct to say? Yeah, it is correct to say this. Why? Because this, you are defining now an object based on the computer terms, or a software object, right? So it is a collection of data and methods that act on the data. So it means what? In this case, you will look at, when they say a collection, you will look at it as, you cannot only have one, okay? You can have, you have a kind of a template. What I want to understand by your collection, you have a template, and then on this template, you are building, you can build several objects. Let's say if you create a template student, for example, you define all the properties that, all the attributes that the student will need. That is the data about the student. You define all the methods or the functions that the student can respond to, okay? And then you do what? Each time you can create as many students as possible using this template. So it will just be like a form, or yeah, a kind of a form that you will use it to create many students. You will just create a template student, which is a collection, and then several students will be created. And those students will have their data. Each one will have their data, and they will have the methods. They will respond to the functions or the behavior that is peculiar to the student. So this definition is correct, GK, it's fine, okay? It's fine. So I believe that we now understand what we mean by real life objects and how you can translate them into computer objects. There is an example I think the example we are going to see later on. Okay. Okay. They took an example of a bicycle. Okay. A bicycle has what? A bicycle has a state. State in this case is like the data about the bicycle. In GK's definition, state is like the data about the bicycle. It is about the characteristic of a bicycle. So it will have what? It will have the current gear. It will have the pedal, the cadence of the pedal. It will have the current speed, okay? And then there is some behavior that the bicycle can have. The behavior is to do what? The behavior is to change the gear. You might want to change the gear of the bicycle. You might want to apply some brakes or change the current speed of the bicycle. You might want to change the pedal cadence of the bicycle. So these are things that are possible that you can do on the bicycle. So it means once you create an object, or once you need to have a template, subsequently we'll see that this template is actually what we call a class in Java programming language. You need to have a bicycle. And for every bicycle, there are some basic states that the bicycle will have. Before you characterize something as a bicycle, it should have this, it should have this, it should have this. And now you will need, it has a behavior or some functions. You might need, you are riding a bicycle, you need to apply some brakes, okay? When you apply brakes, what do? You change the current speed of the bicycle. Maybe the speed was 1 meters per second. You now apply some brakes, the speed becomes 0.5 meters per second. Okay, so but if this function is not there, this function is not there of applying brakes, if it is not there, you will not be able to change the state of the bicycle. You will not be able to control the bicycle. So the bicycle object should be able to provide you with a kind of an interface or some functions or methods that will enable you to control it, to change its initial state. For example, if you have a student and the student was like, last year we were in level 200, and this year we are now in level 300, okay? And in the student object, we had the level, right? The level was there. Maybe last year in your level, you were in level 200. This year, you are in level 300. Now, there should be a behavior or there should be a method in the student object that will enable us to update, to change the level of the student. To say that that student last year was level 200, this year the student has changed to level 300, for example. Okay, it is important. If you create your objects and you don't take into consideration all these methods that the object will, all this behavior of the object, you will not be able to control your object. If you have a bicycle that you don't have a means of applying brakes, it means that the speed of the bicycle will be the same. Okay, and it will not be good. If you have a bicycle that you have the current gear and there is no method that the bicycle gives to you to change the gear, it means the bicycle will remain at the same gear. And that will not be good. So each time you have your object, you must define some methods or some behavior that will enable you to control the state of the object. Okay, we are going to understand that more. We should not elaborate more on that. We are going to understand. Now, we have advantages of building code into objects. Okay, we have some advantages of using the object approach into programming. The first advantage is modularity. Okay, modularity simply means you can handle in your program, you can have about 100 objects. You will have the object students, you will have the object course, you have the object lecturers, you have the object lecture halls, you have the object laptops. And now these are modular, these are independent, although they interact with each other, but they appear as independent elements, okay? That you can independently handle them. It means you can decide and say, okay, I want to tackle the student object. You tackle it, you handle it, and you finish with it. And you say, okay, I want to handle the course object. You handle the course. I want to handle the lecturer object. You handle the lecturers. And then you see that they are kind of modular. They are kind of independent. But at the end of it, they are communicating with each other to form the whole system that you are building. Okay. So when you use the object approach, you have this advantage of modularity, and it facilitates development, and it facilitates also, let me say, specialization. You can just say, since we are about, in this course, we are 20 of us. If we have 20 objects in our system, we can say, okay, Ivo, you handle the first object. Chabi, you handle the second one. Celeste handles the other one. Angela will handle the next one. So that's, you can do that in your programming. And at the end of it, all these persons will bring all their objects that they have created, and then you will assemble them to have the whole system. Okay, to have the whole system. So that is the advantage of modularity in objects. Then we have information hiding. Okay, information hiding simply means Chiabi will not need, if Chiabi was working on the student object, he will not need to understand all the functions or the attributes or the state that that Nginx implemented in the lecturer object. Okay, that information can be hidden, but all he needs is to see that which functions is he providing that he can use. If there is a function to change this, the level of the student from level 100 to level 200, for example, then I don't need to understand the details of what is going on in that method. The complexity of the algorithm in that method. I don't need to know it in order to use this method. I simply just call the student object and I call this function and I update the information. I don't need to understand that, in order to change the name of this or the level of the student, they were using the square root function, or they are using the sine function and all of that. I don't need to know. This information is hidden. I just need to call the method, and I give the intended input, and I'm expecting the output. Okay, so that's the advantage of information hiding. People can specialize, and you will not bother going into the details of what is in which object. Then we also have code reuse. Code reuse simply means you can reuse code. Maybe you are working on an application and you see that someone had implemented a student object somewhere. You can import this object in your own application and you use it. Okay, you can reuse code that was written by other developers. You can use them in your own application. Okay, I believe we have less than a minute to stop. So we'll connect back quickly on the same link when it stops. And when we come back, if you have any questions, we shall address them.